Okay, so it's done. The installation is done. Now we can, for example, uh, we can execute other stuff. I think it's done though, but it says it's still loading. Let's wait for a couple of seconds. But I'm pretty sure it's already done. Yes, it's done. Okay. So now, after this, what we're going to do is exit, because we're going to find a problem. I'm going to tell you what in a moment. We're going to exit. So we'll fix that problem first. Yeah. We can exit with Ctrl C and shut down the notebook with yes. If I open again notebook, there will be it will crash. So, and even if I open Ubuntu again, it will crash again. So what we're gonna do, how we're gonna fix this, we're going to fix this with the following command. We're gonna put conda update --all. So if we do this, we'll have to wait a little bit while again, but after this we will be able to use Phoenix. In the meantime, we downloaded this Poisson, so we're going to open it. And we're going to do the following. We're going to go to Jupyter Notebook. You can try Jupyter, and we can try Jupyter with Python. So, and we will be able to download it. So we're going to do the following. We're going to set up this. We're going to copy this and copy it here. A big catch though, this demo won't work here because Phoenix is not installed in this library. I'm only doing this to show you, to win a little bit of time and to segment the code for easier understanding. So yeah, I'm just segmenting the code to make it a little bit more friendly and more Jupyter-like. And meanwhile, I will show you a couple of Jupyter Notebook features that I think are really cool. So let's keep going. Yeah. Okay. So we have this. However, we can also do the following if we want to do. We can separate it even more, and we're going to do here is put markdown, and we're going to make this way. Okay, this is written in markdown. So if I do Shift Enter, it says implementation. So it will be much more friendly for us to see. So if I change to Markdown again, so it will be easier to see. Again, we go to Markdown and do this. I'm doing this manually just to manually convert the Python tutorial to the Phoenix tutorial. But I mean, it's kind of a bad idea to do it by hand. But since we have time, because this is still running, so we can do this. Just to show you this. And just to show you that with Phoenix we can make an interactive notebook that is very beautiful. For example, we have here text and we have code at the same time. That makes it really friendly for you to teach, and moreover to share with other people and to make them understand. I think that's one of the best, coolest thing of Jupyter Notebooks, and is that the code is very easy to understand if you really take your time and make it friendlier for people. Yes, and it will, and I think that's something really cool about Jupyter Notebooks, that allows people to, well, understand, to share, and to how can I say, yeah, really make a part of a big community of open source, and of on also, rather than open source. Okay, now we need to proceed. Rather than open source is in the sense of people that can check that your results were correct, that can check and can build upon your ideas. So it's more of what I believe the scientific method was like, yeah, a very, I would say, utopical way of sharing your work. But I still believe it's very cool. I remember the word now. It's very cool for reproducibility of work. Yes, because you can reproduce works from other people. You can really see that what they do makes sense, and you can build upon the work of other people and understand what they are doing. So I really find that cool. Which sometimes, even with source code that is freely available, it's very difficult to understand, and people don't make it in a way that is understandable and transparent for other people. Yes. Okay, this is the very last part. Yeah, you can skip all of this if you want. Alright, it's now partially converted. I still have to wait a little bit. So yeah. So let's briefly look at what the code is doing here. So first we import the module Dolphin. Okay, that's something very interesting. Dolphin is the library that went before Phoenix. So many Phoenix things were actually Dolphin stuff before. And Dolphin is a very large library of many things that are implemented in order for Phoenix to work. So we actually import Dolphin instead of Phoenix. However, you can also import Phoenix. That's what's really interesting about it. Okay, now we're going to create a mesh that is gonna be a square mesh of 32 by 32. We define our function space of approximation function space as Lagrange, as polynomials of degree 1. Yeah. So it will be a square grid. It will be a square grid with triangles. So it will be something like this. Yeah. And or usually represented in this way, actually. 32 by 32. We define the boundary conditions as being the Dirichlet boundary conditions. That means that the boundary is going to be fixed in as here as you can see is going to be equal to 0. You define a constant as the boundary conditions and you applied the constant on the boundary. Then you define your trial function, your test function. You have the analytical solution, and you define the gk, that is the Neumann. Sorry, not the analytical solution. The f is the inhomogeneous term, and g is the part of the Neumann boundary condition. So you define your bilinear form and then you solve for u. Note that we didn't really implement the Neumann boundary condition directly, because it was here. We defined it weakly here, and we also define it weakly because it's in the places where x is defined the boundary condition, the Neumann boundary condition. We don't specify anything because it is already built into the solver, because that's why it's sometimes called natural boundary conditions. And then we export the file, the data file, and we plot it. Okay, it's almost done. yeah, after this it will Phoenix will work perfectly. Okay, but before that, remember that we are not in our Linux, but this is rather a trial, so we're going to download this. We're going to download this as a Python notebook, and now we can just go away. We could have changed the name, but anyways, it's called index. Okay, it's done. Great, now we can go and go to Jupyter. Okay, but before that, something really important, and is that since we are in Windows, we don't really wanna work in Linux and change files to files. So before that, we're going to change our default starting directory for our Jupyter with the following commands. Yeah, instead of starting in this very complicated place that we saw, it was C users, Phoenix, app data, canonical, and because it is starting, Jupyter is starting here in this directory, but we will want it to start in somewhere that we know in Windows, for example, documents or the name of or Phoenix, that in Windows, the Phoenix user. So what we're going to do is going to do the following commands. Jupyter. Okay, but let's prove that it's working right now. So we can run Jupyter Notebook, and it's working normally. Okay, so it's working normally, but as I said, it's opening here in Linux in Anaconda 3. I cannot access any file of Windows here, so what I'm going to do in order for this to be more easy, so I'm going to change the starting directory. I'm going to go to Jupyter lab -generate minus config, and I'm going to write this one, nano home Phoenix dot Jupyter notebook config, and here we're going to go with our arrow down until the part Jupyter notebook app notebook dir c.notebook app notebook dir, and it is here, c.notebook app notebook dir. We push delete, and we delete the number sign, and within the quotes, the single quotes, we write /mnt mount /c user users /Phoenix, and then we put Ctrl X, we say yes with Y, and we push enter. Now we did it. Now if we go Jupyter Notebook, we will open in Windows, within Windows. That we have documents here, and we have also downloads, and we have this index that we downloaded that is here actually. and we can actually run it. And now finally we can run Phoenix. So we run it and it imported correctly the dolphin, it created the mesh, and if we want to see the mesh, what we do is plot mesh and plt.plot, and now we can see the mesh. Oh, sorry, it's because I haven't imported matplotlib, so I import matplotlib here, and now we can see the mesh. Is, as I showed you, a 32 by 32 square mesh. We define the boundary, shift enter, we define the trial functions, the test functions, the boundary conditions, the inhomogeneous term, the bilinear form, the linear form. We compute the solution, and we save, you save it to a file and we plot it. Great, we did it, finally. Now, I would like to plot a little bit more. So I'm going to do this extra part that I'm going to show you how to plot with, for example, a color bar, because this information is really difficult to find on the documentation. So how do I plot color bar? It's very simple. Instead of doing this, I'm gonna go to solutions with color bar, and I'm going to do plt, and I'm going to do plt.colorbar, and within, and I'm going to put plot u here. Now I can plot with color bar. Great, right? Now I'm going to use something else. I would like to plot a 3D surface. For this, I'll download this file. I'll put it in the description of the video. I'll put it keep. Since we are in downloads, I'm going to show you something really cool. I'm going to copy this this code that I have. I'll put it also in the description. But what I want to show you is that BoxField is a library from Phoenix, but it's outdated. I updated the library myself, and with BoxField you were able before, this is the BoxField that was from Phoenix, and now it says that there is no module named BoxField. But if I since there is no module anymore, if there is no way to my knowledge to print 3D surface within the Python notebook. So what we're gonna do is put BoxField fixed. That was the library that I fixed, and now with this we can make a surface plot. And something else that I'm going to teach you is that if I put this Python magic command, matplotlib notebook, now I'll be able to move it. Yes, and it will be an interactive. Very cool, right? So that's it. The tutorial finishes here. I hope you learned a lot. That was how to do the installation within Linux inside of Windows, and I'll do the installation of Docker. Of Microsoft Azure Notebooks next, and then Docker. But something that I want to teach you, and is the way why I like this the most, is because I'm going to close this. Okay, first I'm gonna save. I'm going to save. Oops, no, sorry. Save and checkpoint. Then I'm going to quit. And now, instead of opening Jupyter Notebook, I'm going to open Jupyter Lab. That is the updated version. I didn't want it to open Jupyter Lab because it's much more complicated. Like, there are much more stuff that have to be covered, but in principle it's the same. It's a notebook. But also you can, for example, put a console. And, oops, sorry, this is not a console. A terminal. And you can put them side by side. Here is the notebook, here is the... And you can also access at the same time a console, and you can, for example, list your files, or create new files, or manage files from Windows to Linux, and at the same time run your Python. You can also, in the meantime, create text files and put them side by side. And while you do this, you could be doing something here, plotting and solving. Yeah, solving with colorbar. Yes, and even... Okay, and even I should delete this because Jupyter Lab is a little bit different. But anyways, Jupyter Lab, in order for you to do Jupyter Lab, you have to install what's called the matplotlib widget. If you are interested in this, please tell me, but in principle you are fine with this, or look up how to install this matplotlib widget for Jupyter Lab. But in essence, you can do many things here. And that's it. Thank you for watching. Here the tutorial finished.